In this video, we're going to prove in two different ways that the sum of the first n counting numbers is that last number times one more than that last number over 2. When Dr. Gauss, a very famous mathematician, was in elementary school, he and his classmates were talking a bit too much, and their teacher said, as punishment, we want you to add up the first 50 numbers and do not talk until after you finish. So Gauss was very clever. Actually, it was the first 100 integers. So 1 plus 2 plus 3 all the way up to 98 plus 99 plus 100. So Gauss said to himself, well, you know what? I'm going to add these numbers backwards. I'm going to add the same numbers backwards. And he realized, he realized this is 101 and this is 101 and this is 101. In fact, they all add up to 101. So he said that it's 101 times how many times he's adding 101. 1 time, 2 times, 3 times, eventually 100 times. But that's twice what he wanted. He added it twice. So he divided by 2 and he got 50. And he said that there's the answer. And this is basically how long it took him to do this. And he, as directed, started to talk because he was allowed to talk when he was done. And the teacher's like, what are you doing? You're not supposed to talk until you're done. He's like, oh, I'm done. I have the answer. Okay. So well, this wasn't the proof, but there's a quick story about Dr. Gauss. So one way of proving this is just like Gauss did, where we're proving it in general. Gauss would say, well, let's call it S. So you have 1 plus 2 plus 3 up to one number before n plus n. And if you write it backwards, it's still going to be the same sum. And when you add them, the left side will be 2s. And notice, this is n plus 1. Now, if you make this number 1 less and the top number 1 more, it's still going to add up to n plus 1. It's still going to add up to n plus 1. N plus 1, n plus 1. So 2s is, well, if you keep adding n plus 1 to itself, let's see, 1 time, 2 times, 3 times, oh, n times. You're going to get n times n plus 1. Now, if you divide both sides by 2, you get the formula, and the proof is done. Another standard way of doing such a problem is by induction. So let's write up, well, let's have this theorem in front of us. 1 plus 2 all the way up to n is n times n plus 1 over 2. I'm going to prove this by induction. Suppose n is 1. So this is just 1. And does it equal to the other side? Does it equal to n times n plus 1 over 2, which is 1 times 2 over 2, which which is 2 over 2, which equals 1? The answer is yes. Okay, so now we assume for, say, n equals k, that 1 plus 2 up to k is that last number times 1 more over 2. Now we need to show for n equals k plus 1 that 1 plus 2 plus 3 up to k plus 1 is, so I replace k's with k plus 1. K plus 1 times k plus 1 plus another 1 is k plus 2 over 2. Okay, so we need to show this. We don't know that that one's true yet. So 1 plus 2 plus 3 all the way up to k plus 1. So the number before that is k plus k plus 1. Well, you can think of this as 1 plus 2 plus 3 up to k. Let's put brackets around that, plus k plus 1. Well, by assumption, we know what that is k times k plus 1 over 2, plus k plus 1. So maybe I'll factor out the k plus 1. So what's in blue is what I'm factoring out, so I don't write it down in these brackets. But just remember that this is 1 times k plus 1. So I write down exactly what I see here except what's in blue. That is k over 2 plus 1. Okay, so this is k plus 1 over 2. Now, I'll think of this 1 as 2 over 2. So now I have a common denominator. And notice here I don't have over 2, so I shouldn't have it over here. So I write down the k plus 1 k plus 1 times, I have common denominator, so k plus 2 over 2, which is the same as k plus 1 times k plus 2 all over 2. And this is just what I wanted to get, and I did. So we proved the two ways, one using Gauss's method and the second way using induction. That completes this video.